derive a line curve is by simply making a fraction. On the denominator, we're writing the 1 plus the x squared, so what is after the line. And then on the top, we write the derivative of what is on the denominator. So that would be 2x. And that's it. That is how to derive a line function. To find the double derivative, however, now since it's a fraction, we have to use the quotient rule, wherein the top is going to be called u and the bottom is going to be called v. And so our quotient rule states that u dash v as it is minus v dash u as it is all over v squared is exactly how we need to differentiate f dash of x in order to get f double dash of x. So let's go ahead and expand that out. 2 plus 2x squared minus 4x squared all over 1 plus x squared all squared. I would not bother expanding the bottom. It's not really going to take us anywhere. It's just going to spend time. So cleaning that up, we get minus 2x squared plus 2 all over 1 plus x squared all squared. Now, in order for f double dash of x to be greater than 0, therefore the minus 2x squared plus 2 over 1 plus x squared all squared has to be greater than 0, which means that the numerator itself has to be greater than 0. And so let's just focus on that for a second. If we move everything to the other side, that would mean that 0 is greater than the 2x squared minus 2. That would mean that the 2x squared minus 2 is actually less than 0. If we take 2 out as a common factor, we get x squared minus 1. And so dividing everything by 2, we get x squared minus 1 is less than 0. Factorize that, we get x minus 1, x plus 1 is less than 0. And so if we were to graph that, because you've got to graph any inequality in order to be able to solve it properly, you've got solutions of minus 1 and 1, but since they are not included in our inequality, they will be denoted with open circles. Our curve, which is our parabola, is going to be concaving up like so. And now our question remains, where is our curve less than 0? Where is it under the x-axis? And so it's under the x-axis in this section here. And so therefore, that is going to be where x is in between 1 and minus